Hey guys, so sorry that I haven't gotten a video to you guys sooner. I had a very elaborate review of chapter 7, but it will not let me upload it to YouTube because it's so long. So I'm going to try and make this short, but include all of the most relevant details from chapter 7. The very first thing you guys probably talked about in chapter 7 was the integers. So with integers, there was a couple things that you guys can do with that, but the main focus was making sure that you all know how to add, subtract, multiply, and divide those integers, so the positive and negative numbers. So positive numbers, anytime you write a positive number, you can either write it with a plus sign in front of it. So if I was writing positive 5, you can either write it as plus 5 or with just the number 5. That also indicates that it's a positive. I just don't have to put the plus sign in front of it. However, anytime I want to write a negative number, I have to put that negative symbol in front of it, so I would write it as minus 5. The best way to kind of think of integers and think of these positive and negative numbers is to remember that positive integers always mean, if we think of it in terms of money, positives being something that I have, whereas negatives being money that I owe. So as we add and subtract those, that's going to really come in handy if we think of it in that manner. So going through a couple practice problems, just starting first with the addition. When you're adding two integers that have the exact same sign, those are pretty easy. If you add two integers, say if I'm adding 6 plus 8, those are both positive integers. I don't have to write the plus sign in front of it, but we know what 6 plus 8 is. 6 plus 8 is 14. So you can see what has happened here is if I add two positive integers together, my answer is a positive number. So two positives equal a positive. In other words, if we think of it as money, if I have $6 in one pocket, or I have $8 and then I have $8 in the other pocket, then together I have a total of $14. And that makes sense. I have that amount of money. Whereas if we were to reverse that and say that we've got negative 6 plus negative 8, again, two integers with the exact same sign. Another thing I want to point out in this is when you're looking through your book, sometimes your book does this and puts parentheses around a number. The reason why they do that, nothing to be thrown off by. All they do that is to make it easier on our eyes as we're adding these integers together so that I don't have a plus minus right next to each other. Makes it a whole lot simpler. So I've got here negative 6 plus negative 8. If I think of that in terms of money, again, negatives being something that I owe, if I owe $6 for one thing and then I owe $8 for another, so say I'm at a grocery store and I'm buying something that's $6 and another item that's $8, then together I'm going to owe a total of 14. So you can see the pattern that it has taken there, that when I add two negatives together, I get a negative answer. So my rule is this: when I'm adding two integers that have the same sign, my rule is to simply go ahead and add them together, but keep that sign. So if you just remember, add together and then keep the sign. Add together, whoops, I don't know what happened there. Keep the sign. That's our rule for integers with the exact same sign. So as you can see here, I'm adding together two positives at the top and then two negatives down at the bottom. So they have to have the same sign in order to follow this add together rule. We just add them together like we always do, but keep the sign in the problem. It's going to look a little bit different when I'm adding integers of opposite signs. And again, really easy way to think about this is to think of it in terms of money again. So let's use the same numbers, but we're going to make them opposite signs. Let's say I have positive 6 plus negative 8. So again, I'm going to put those parentheses around it just to separate the plus and the minus there. So in this case, if we think of that as that I have $6. So I go into a grocery store and I've got $6. But I'm trying to purchase something that's $8. So I owe $8. Well, if I only have 6, but I owe 8, then technically I'm still going to owe another $2. So that's where my answer is going to come in here. That and we kind of think of that scenario. If I have $6 but owe 8, I still owe another 2. So that's why my answer comes out as negative 2. Even if I were to reverse these two numbers and say that let's say we have negative 6 plus positive 8 this time. Still opposite signs, but again, thinking of kind of a similar scenario. If I owe $6, but I have 8, well then therefore I'm going to leave that store still having $2 in my pocket. So you can see in both scenarios here, I still come up with the answer as 2, but in one case the answer is -2, the other case the answer is +2. So my rule for opposite integers is this: when they are the opposite of one another, what actually happens is I subtract their values. I take 8 and subtract 6. I always take the bigger number and subtract the smaller number to get that 2 in our example. I got my answer as 2, but then what I'm going to do is I'm going to keep the sign of the larger value. In both cases, 8 is always going to be bigger than 6. And in the first example, because 8 was negative, that's why my answer was negative. And in the second answer, because my 8 was, or the second problem, I'm sorry, because in that second problem, the 8 was positive, that's why I ended up giving a positive to the 2. So my rule is that I simply just subtract their values, but keep the sign of the larger value. So doing another problem, because I know that sometimes that one gets kind of tricky. If let's say I have, I don't know, let's say -10 plus +3. And so in this case, it doesn't matter what order your numbers come in, which one's positive, which one's negative, no matter what, because they're opposite signs. That first one is negative, the second one is positive. My rule is to remember this, that when they're opposite signs, I'm going to subtract their values. 10 minus 3 is 7. And I'm going to keep the sign of the larger value. 10 is bigger than 3, so because 10 is negative, so is my 7. And thinking of this in terms of that money again, if I owe $10 but I only have 3, then I'm still going to owe another 7, and that's where that -7 comes in. Trying another one, just to make sure we feel pretty comfortable with just that rule. Let's say that we have, I don't know, we'll say +4 plus -9. In this case, and I'm going to go ahead and just separate that so we can separate the positive and the plus and the minus. Opposite signs, +4 plus -9. One's a positive, one's a negative. My rule again is to subtract their values. 9 minus 4 gives me 5. But because my bigger value in this case was negative, so is my 5. So we're seeing the same scenario here just like we did in the previous problem. I have $4, but I owe $9 for something, so therefore I still owe another 5. So that's opposite signs. Opposite signs, remember to subtract their values, but keep the sign of the larger value. All right, let's take a look at subtraction then. Subtraction, what I'm doing there is I want to go ahead and with that subtraction, let me just give you a scenario. Let's say we have 6 minus 8. I don't know. We're going to use the same two numbers that we looked at earlier. In this case, this one might be a little bit easier because it's easier to think of this as money. If I have $6 in my bank account, so positive is being something that we have, and I go to that, again, remember that this is subtraction. If I go to withdraw $8 more out of that bank account, but again, I only have 6, but I go to take away 8, then I'm going to end up in the negatives here. So obviously, if we're using the scenario of money in my bank account, not taking into account overdraft fees and all that fun stuff, 6 minus 8 in this case is going to give me a -2. Again, because that's what's happening, is that now I'm going to end up owing the bank $2 because I took $2 extra out of my bank account that I did not have. So that's kind of an easy way to think about that. Whereas if I were to use kind of a similar scenario here, let's say instead I have $6 in my bank account, but now I go to take away -8, or I'm sorry, -8. I don't know why I said -8. I go to take away -8. What the heck does that mean in terms of money? Well, in terms of money, again, that's what I'm saying. And in this scenario, I have $6 in my bank account. What I'm trying to take away, though, is a negative. So a way to think of it in terms of money is as if the bank is forgiving me of a debt. So meaning that they've decided that, hey, we thought you paid $8 for something, so we took it out of your bank account, but now we want to forgive you for that debt, so we're going to put it back into your bank account. So if I withdraw a negative, what's going to end up happening here is my bank account is going to go back up to $14. Because they're, like I said, they've forgiven me of something that they thought I had paid $8 for, but they decided that that was wrong, so they're putting it back into my account. So 6 plus 8 gives me 14. So that can get pretty tricky. I think in this case, your best bet, what your book covers with you, is to remember one simple phrase. If you remember the phrase, add the opposite. This is actually very similar to our division of fractions. If you guys remember, for our division of fractions, we applied the keep, change, flip principle, which meant that we were keeping the first fraction. We changed the division into multiplication, and then we flipped the second fraction. Very similar here. If I remember this phrase, add the opposite, I'm going to do something pretty similar. I'm going to keep the first integer the same as it is right now. So in both examples, that's the 6. So I keep. What I'm then going to do is I can change the subtraction into addition. So I'm going to look at the first one first, the 6 minus 8. If I change that subtraction into addition, and then we're going to flip, in this example it's not necessarily flip, but I'm flipping from the positive to a negative. That's what I mean by its opposite. Is if I'm taking the opposite of something, of any positive, is its negative, or the opposite of a negative is its positive. So in my first example, I changed that subtraction into addition, and in turn I would have to change that positive 8 to a negative 8. So if we remember, add the opposite every single time, I'm changing it to addition, changing the second integer into its opposite sign. So positive changes to negative in that example. So then, if you take a look at that first problem then, what we have now is an addition problem. And I know my addition rules for integers say that now that I have positive 6 plus negative 8, I have opposite integers here. And my rule for adding signs of the opposites, or integers of the opposite sign, is to go ahead and subtract their value. 8 minus 6 is 2. But I keep the sign of the larger value, which is the negative. Whereas in the second, if I apply the exact same rule, the second problem down at the bottom of your screen there, I have 6 minus negative 8. The signs right now don't matter. Doesn't matter at all. It's not until I change it into addition that's when that's gonna matter. So if I remember the phrase, add the opposite, I'm changing that subtraction into addition, and I'm going to change the negative 8 into positive 8. That would be the opposite. And now what I'm looking at are two integers of the exact same sign, and my rule for that was a little bit different. If I have two integers of the exact same sign, I simply just add them together and keep that sign. So 6 plus 8 gave me 14. So if you just remember in any subtraction problem, simply remember to add the opposite and then sit back and look, okay, now that I have it as an addition problem, what are my signs? Because that's going to matter how we then approach that addition problem. So remember those two rules. So that's addition and subtraction of our integers. So now let's get into the multiplication and division. Multiplication and division, same two rules. As long as you remember these rules, you'll be absolutely fine. Multiplication and division, as long as you have the same sign in your problem, your answer will always be positive. Meaning if you're multiplying two positives or even two negatives, if they're both the same, your answer will be positive. However, if your signs are opposite, meaning you're multiplying a negative times a positive or a positive times a negative, then your answer will always be a negative answer. So if I go back to the two numbers I was using earlier, the 6 and the 8, let's say I have 6 times 8. Well, we know 6 times 8, we know that 6 times 8 is 48. Sorry, I'm distracted by cell phone. 6 times 8 is 48. So 6 times 8 will always be 48. But because it's a positive times a positive, we get a positive answer. Whereas then if I had negative 6 times negative 8, I would actually get the exact same answer because they're both the same sign. They're both negative. So my answer will also be positive 48. Again, 6 times 8 is always going to be 48. But we're just looking at determining the sign. The only time you'll get a negative answer in a multiplication problem is if you have mismatched signs. So I have negative 6 times positive 8. That's going to give me my negative 48. Or if it was reversed and it was positive 6 times negative 8, I would also get negative 48 in that problem. So that's a little bit easier with the multiplication. If you just remember that same sign equals positive, opposite signs equals negative. And it's actually the exact same scenario in division. If I'm dividing two integers, let's say I'm going to use two different numbers this time to show not the same type of problem, but let's say if I have 30 divided by 6, and I'm going to write it as a fraction, that's the same thing as 30 divided by 6, guys, but I know in your book you saw it the other way. So either way, these are how you write division. 30 divided by 6 is always going to be 5, but because they're both positive, my 5 was also positive. It'd be the same thing if I change these to negative real quick. 30 divided by 6, again, is always going to be 5. And negative 30 divided by negative 6, because they're both the same sign, is also going to be positive 5. The only time you get a negative answer in this scenario is if only one of them was negative. So if I have negative 30 divided by positive 6, I'll get that negative 5 this time. And same thing if it was reversed. If it was positive 30 divided by negative 6, because one's a positive and one's a negative, then I'm going to get the negative 5 again. So remember that. So with our integers, remember addition of the same sign is to go ahead and add together and keep that sign. Whereas addition of opposite signs, we actually subtract their value and keep the sign of the larger value. For subtraction, remember add the opposite and then incorporate your addition rules. And then for multiplication and division, remember same sign equals positive answer, opposite sign equals negative answer. Hope that helps with your integers. Okay, next you guys probably ran into, after you all discussed integers, you guys probably talked about exponents. Exponents, whenever we have a number with another number written in the upper right hand corner, the big number is referred to as the base, and the little number is referred to as our exponent. What that exponent means, like in the example we see on the screen here, 4 raised to the third power, what that means is I want to take 4 and multiply it 3 times. So not to be confused with 4 times 3, which would be 12, 4 to the third power is actually going to be 64, because it's 4 times 4, which is 16, and then 16 times 4 is 64. So anytime you see an exponent, that's what that means. Another thing to remember as you guys are going through the chapter, anytime you see any number raised to the power of 0, that number is always going to be, the answer to that will always be 1. So anytime you see that, just know that that's going to be equal to 1, just in case you ever come across, like if I had 7 to the 0 power, my answer would be 1, just FYI. Or 18 to the 0 power, my answer would be 1. So anytime you see that, just in case, but just remember that anything raised to a power means to multiply it that many times. So on a test, if you ever saw 5 raised to the power of 2, sometimes that's referred to as squared, so that would be 5 squared, which simply means to take 5 times 5, so the answer would be 25. If I had, let's say, 2 to the power of 6, for instance, then that would be 2 to the 6th power. Let's see, that's 2 multiplied 2 times. It's 2 multiplied 6 times. So 2 times 2 is 4, times 2 would be 8, times another 2 would be 16, times another 2 would be 32, and this times another 2, my answer here would be also 64, kind of like the one we saw earlier. So just FYI on that, so you know what exponents mean. The other thing that you guys saw were probably square roots. Anytime you see a number in a bracket, I'm trying to get this off the screen here, there it goes. Anytime you see a number in a bracket like so, what I'm looking for is the square root of 16. What I'm asking for the square root of 16 is I want to know what squared will give me 16. And what we saw a second ago, squared means raised to the power of 2. So what multiplied by itself will give me 16? Well, I know that 4 times 4 is 16, so therefore the square root of 16 is 4. Some other examples include if I'm looking for the square root of 81, I know that it's 9 times 9 that gives me 81, so therefore the square root of 81 is 9. Or perhaps the square root of 36, well, it's 6 times 6 that gives me 36, so the square root of 36 is 6. And that's a square root. Next thing you guys ran across were the order of operations. So the order of operations, we could remember either PEMDAS or please excuse my dear Aunt Sally as a mnemonic device to remember the order of operations that we should follow here. So in the order of operations, P stands for parentheses, E stands for exponents, M stands for multiplication, D is division, A is addition, and S is subtraction. One thing I want to point out, this is not a 6-step process, although it looks like there are 6 letters up on the screen there. It's actually a 4-step process. And what I mean by that, I'm going to look for parentheses first. Exponents or square roots are included in the exponents category there. Exponents second. Next, I'm going to look for multiplication and division together. So meaning, as I read that problem from left to right, whichever one comes first is the one that I'm going to solve first. So in giving an example on the screen here, if I had 8 divided by 4 times 2, some people think that multiplication has to come first here, so our answer to this should be 1, which is actually not the case at all. It definitely should not be 1. Some people think that we should take that 4 times 2 to get 8, and then 8 divided by 8 is 1. Not the case. What I mean by that step being multiplication and division, I'm going to now read my problem from left to right. And because it's just division and multiplication in this problem, I'm going to go ahead and take 8 divided by 4 first, which gives me 2. And then I'm going to take that and multiply it by 2. My answer here should be 4. So, just FYI, the same case goes for step 4, which is addition and subtraction. Which means, as I read it from left to right, I'm going to do whichever one of those comes, or I'm going to perform whichever one of those comes first. So just FYI on that. So if I had a big problem that had... I don't know, let's say 16 divided by, let's see, put this in parentheses here. How about 8 minus 6, I don't know, times 3 squared minus 2 plus 4. I don't know how this is going to work out, so we shall see. Anyway, so I created this problem to show that there's lots of different things that are happening in this problem, and the temptation is to go ahead and just read it from left to right and start with 16 divided by whatever that number is in the parentheses. Not the case. We got to follow the order of operations. So remember again, please excuse my dear Aunt Sally, follow that 4-step process. So the first thing I'm looking for is parentheses. I do have an operation inside of my parentheses, and so I'm going to take 8 minus 6 first, which we know is 2. My suggestion to you guys is as you all solve your order of operation problems, go ahead and write what you're left with so that you can see what to do next. So meaning, all I did was solve what's inside the parentheses, so I'm left with 16 divided by 2, we solved that, times 3 squared minus 2 plus 4. Okay, same case. I'm going to look for now, so we've solved the parentheses, now I'm looking for exponents. We do have an exponent in this problem, 3 squared, so I'm going to solve that. 3 to the power of 2 means 3 multiplied twice. 3 times 3 I know is 9. So that means I am left with 16 divided by 2 times 9 minus 2 plus 4. Okay, so now I'm looking for M and D. So I'm reading this from left to right, and whichever one comes first is the one that I'm going to solve first. In this case, it happens to be the division. So I'm going to take 16 divided by 2, which I know is 8. So I have 8 times 9 minus 2 plus 4 left in my problem. So again, the next thing I would solve is the multiplication. 8 times 9 we know is 72. So let's see, I'm going to switch to another marker here, or color here. So I have 72 minus 2 plus 4 left over in this problem. So now the last step, I've solved on my multiplication and division, and now I just need to add and subtract. But reading that from left to right, it looks like subtraction is going to be first here. So I take 72 divided by, 72 minus 2, which is 70, and then plus 4. My answer here is 74. So that's how you solve your order of operations problems. And like I said, I suggest doing what I did on the screen and solve one step at a time, write what you're left with so that you can see as you continue on with the rest of the operation. Next thing you guys ran across, as you all were going over chapter 7 the other night, you guys probably solved for some missing variables. I know that the rest of the chapter was all about taking word phrases and word problems and being able to turn them into algebraic expressions. But if the test that your instructor is going to use, I have a feeling if he's using my test, you guys won't see too much of that until you get to some word problems. And that's how you turn them into equations. But what we have to do before we even know how to do that, we want to be able to solve for those equations. So what I mean by that is whenever we're solving for x, so if any variable, if a variable is a letter, the letter used in place of an unknown, something that I don't know. So for instance, if I have, and x is just the most commonly used variable, so if I have x plus 5 is equal to 15, obviously I know that that's going to be 10 because I know it's 10 that I have to add to 5 to get 15. But what do I do when I'm solving for a missing component? In this problem, what I want, and I'm kind of basing everything across this equal sign, where I'm going to call this side the left side of that equal sign, and this side I'll call it the right side of the equal sign. Over on that left side, I have x plus 5. I want x by itself, simply because I want this problem to say x is equal to something. Doesn't matter, I mean, again, that's what we're trying to do, is we're trying to solve for that something. But right now it says x plus 5 is equal to something. So what I want to do is I want to get that x by itself. So in other words, I need to remove that 5 from the left side of that equal sign. And how we remove something from a problem is I do the opposite of what's being done. So right now, because I want to get rid of the 5, and the 5 is being added to my x, what I'm going to have to do is I'm going to have to subtract it from my x. So I'm going to subtract 5, and what that's going to do is it's going to cancel out those 5 since it's the opposite. But we also have to remember what equals means. Equals means that whatever I have on one side of my equal sign, it's the same over on the other side. It's equal to that side. So if I do something to one side of my equal sign, I have to do the same thing over on the other side. So because I had subtracted 5 over on the left, I need to subtract 5 over on the right. And so what happens is, since my 5s have canceled out, it left me with the x just like I want. I want it by itself. But over on the right side over here, I have 15 minus 5, which we know is 10. So that's how, you solve for something that maybe is being added. The opposite would happen if I had something that was being subtracted. Like if I had x minus 3 is equal to 18, well then what I need to do to both sides of that equal sign to get rid of that 3 is add 3. So over here my 3's cancel out and leave me with x, whereas over here 18 plus 3 is going to give me 21. So therefore x is equal to 21. Again, so you're always doing the opposite of what's being done. So same case goes for if I have a variable that's being multiplied by a number, and the way that you will commonly see this written is you may see something like this: 5x is equal to 20. When you have your variable written right next to the number, that simply means to multiply by that variable. So what I have on the screen here is 5 times something, that x, is equal to 20. I know that it's 5 times 4 that's going to give me 20, but how do I figure that out for the ones that maybe aren't as easy? Well, because 5 is being multiplied by the x in this case, I'm going to have to do the opposite of multiplication, which is division. So I'm going to divide by 5 on this side. What it will do is it will cancel out those 5's, leaving me with just x. And over on the other side, I have to do the exact same thing. And 20 divided by 5 we know is 4. So x is equal to 4. Another thing you can do if you're ever unsure if you did that correctly, what I'm looking at is this says x is equal to 4. Well, if x is equal to 4, then I should be able to plug that x right into my original problem and test to see if I was correct. And so that should mean that 5 times this number is equal to 20. And that's right, 5 times 4 is equal to 20. So we did do that correctly. So just FYI on that. And then division, we know that the opposite of division is multiplication. So if I have x divided by 4 is equal to, let's say, 8, then I need to get rid of that 4. And in order to get rid of the 4, since it's being divided, I need to multiply by the 4 in order to cancel it out. That leaves me with just my x on that side, but I multiply by 4 over on the other side, and that leaves me with 32. So x should be equal to 32 in that case. Okay, so let's get this off of the screen. I want to show you something else that you may run across in solving for variables as well. If you ever see two things happening to a variable on that left side of the x, or left side of the equal sign, if you have something like 5x as well as minus 3 is equal to, I want to use something, let's say 22. Yeah, that should work. That'll come out easy. So what I have over here, again, this is the left side and this is the right side of my equal sign. Now I have two numbers that I need to get rid of in order to get x by itself. Whenever you see this, get rid of whatever's being added or subtracted first. So you're kind of thinking whenever you're trying to get rid of numbers, you're kind of thinking in the opposite of order of operations. That, addition and subtraction were the last step in the order of operations, but in getting rid of numbers, that's actually going to be our first step. So I want to get rid of that 3 before I get rid of the 5. Always. Always, always, always get rid of whatever's being added or subtracted first. So because 3 is being subtracted, I'm going to add it to both sides. And so what that will do is it'll cancel out my 3's. It will leave me with 5x over here on the left side, and it will leave me with 25 over here on the right side. Now this just becomes a two-step problem. Now I have 5x is equal to 25, so I need to get the 5 off of my x. So just like I've done before, because it's 5 times x, I'm going to divide by 5 in order to get rid of it. And I'm going to do it on both sides of the equal sign. Canceling out my 5's over here, leaving me with x. My 25 divided by 5 over here is 5. So again, therefore x is equal to 5. Even more important in this case to go double check your answer. If I plugged in my answer to that x, I said that x was equal to 5. If I plug that in for x in the original problem, I can double check my work. 5 times 5 I know is 25, minus 3, yep, it is 22. So we did that correctly. So just doing another one of those. Let's say I have x divided by 4 plus 5 is equal to 10. Well, then what I have here is if I need to get rid of the 5 first because it's being added. So I need to subtract 5 in order to get rid of that. And so over here it cancels out my 5's and leaves me with x divided by 4. And over here, 10 minus 5 is equal to 5. And then because I need to now get rid of that 4, and it's being divided, I have to multiply that on both sides. So on this side, I'm left with x. On this side, I'm left with 20. So if I were to plug that into my original problem, if I said x is equal to 20, I could plug that in and see, yep, 20 divided by 4 is 5, plus 5 does give me 10. So we did that correctly. So that's how you solve for a missing component in pre-algebra. The last thing you guys did in that chapter is you were able to take word problems and turn them into equations. I do not have my book in front of me right now. I'm trying to think of some of the word problems. I know there was one, I believe it was either number 2 or 3 in the last section in chapter 7. If you're looking at some of those word problems, I know there was one that says if you decrease a patient's pulse by 8 beats, it will be 78 beats a minute. The question then says how many beats a minute was the pulse before the decrease? Something along those lines. So you can kind of, if you're following along in your book, you'll see what I'm talking about. So you have to be able to take those word problems and try to see what's being asked of you and be able to turn it into an equation. So if I'm using that particular word problem, the question itself, so meaning just the last sentence in that number, says how many beats a minute was a pulse before the decrease. So I'm going to use the variable p to show that I'm looking at the pulse before the decrease. Then I go back at the rest of the problem and try to see, okay, well, what did I do to that pulse? Well, the question itself again said, if you decrease a patient's pulse by 8 beats, so to decrease means to subtract, so I'm going to go ahead and decrease it by 8, and then it says it will be 78 beats a minute. So meaning it will be equal to 78. So here I've turned this into an equation. All I have to do now is solve it in order to get the solution. And so what we've done before, again, because 8's being subtracted, I'll add it to both sides, and then I'm left with p is equal to 86. Like I said, I can't remember if that was number 2 or 3. I think it was number 3, because I think number 2 was the one about the jacket and the apron. That's sad how much I have that book somewhat memorized. But I know that's an example I've done in my classes. But that's how you can take word problems and turn them into equations. You just have to be able to read what's being asked of you. So I hope that helps with a real quick summary of Chapter 7. If you guys have any questions over the weekend, please, please, please send me an email. I'll be there all day on Monday, so if you guys happen to come early, my afternoon class is in your all's room, so I'd be glad to talk with you guys a little bit about it if you need me to. Thanks, guys. Have a great weekend.